Welcome to this video. We're going to look at the answers to solutions in class activity part C. So in question 1, they're asking us to identify the colligative property. So remember, a colligative property is a property that depends on the number of particles in a solution, but it does not depend on the type of particle. So we analyze all of these: freezing point depression, osmotic pressure, vapor pressure lowering, boiling point elevations. Those are all affected by the concentration of what's in there, but it doesn't matter what is in there. So all of those are colligative properties. And question 2, you probably wouldn't see this type of question on an exam, but I thought this was just interesting. And I know we have some geology majors in here, and I think opals are really pretty, but also if you are an October baby and your birthstone is an opal, or you just have opal jewelry, I think this is something important to know. So the opals are really pretty, you know, that they have this iridescent color to them. But part of what gives them this color is because it is a solid emulsion. So part of that emulsion is you've got water trapped on the surface here. So this is the silicon oxide, and you've got waters on here, and that helps give it this iridescent properties to it. So if you have opal jewelry, wear it, because what's going to happen is when you wear the jewelry, it's going to rub up against your skin, and your skin has natural oils, and that oils is going to form a fat layer over the opal, and it's going to protect that water from evaporating. Because if you don't wear it, and if you clean it with something very harsh and drying, that water can evaporate, and when that water evaporates, the opal can crack, and so it loses some of its luster. And so to protect that opal, wear that pretty jewelry. So I thought that was interesting. And so this is more of a reading type question. So as we look at the types of mixtures, so I just thought this would be interesting to throw in for the in-class discussion. But question 2, here we're looking at osmotic pressure. So this is, again, one of those colligative properties. And we typically see osmotic pressure when we hear osmosis. We usually think of two different examples that most students have heard of. You either have heard of reverse osmosis, so that's how they purify drinking water from really salty water, or they talk about osmosis when it comes to cells, the osmotic pressure in the cell. So when cells are really happy, we have an isotonic situation. So iso means same. So you have the same amount of force outside the cell as you do inside the cell. And that is related to the concentration of the things dissolved in the cell versus outside. So when you have this happy balance, water's coming in and going out, but it maintains the same volume of the cell. Now, if for some reason your cell, you know, it's too salty inside the cell, there's too many things dissolved, more water is going to go into the cell. And so more water is going to go into the cell. And what's going to happen is that the cells are going to get larger and larger because the water is going into the cell, trying to dilute the concentration in the inside of the cell so it matches the outside. So that when the water goes in, sometimes the cells get larger and sometimes so large that they actually rupture. So this is a hypotonic case. Now, when the concentration is too high in the side, so this is a hypertonic situation. So the concentration inside the cell is too high, or sorry, too low.